Alright, so today what we're going to do is we're going to sum the series from 2rad3 times the series from 0 to infinity, and my infinities are really badly drawn here, but whatever. It's from 0 to infinity of -1 to the n over 2n plus 1 times 3 to the n. And this series is pretty cool because, well, if you don't know what last Sunday was, that was in fact the notorious Pi Day, named, of course, after Sir James Pi, but not really. It's pi is just this really cool number that, anyone who's a student of math will probably use a lot, be it with trigonometry or circles or what have you. So one of the first things you want to recognize is that you have this cool -1 to the n over 2n plus 1 going on here. And if you aren't really familiar with your Taylor and Maclaurin series or your power series, you should definitely check out Patrick JMT's videos for those. Because what this means is that if you can recognize it, the key observation to make here is that the series up here, that part of the series represents the arctan, because you have this thing over 2n plus 1, and you have an alternator up here, like -1 to the n, which you see in arctan. So what you want to know is that this 1 over 1 plus x squared, which, as most of you know, is the derivative of arctan, is equal to the power series of, from n to 0 of infinity, of -1 to the n times x to the 2n. This is important to make because what you can do from here is you can integrate it. And after you take the integral, you get something to the tune of arctan of x is equal to x to the 2n plus 1 times the alternator, which you'll see you should know that why it's called the alternator, because for every n term it will alternate. It'll become, negative, positive, negative, positive. Or if you're starting with 0, positive, negative, positive, negative. And then you have over 2n plus 1. And this is something that, if you don't know it, you don't know it, but you should really start, like, if you're a student of series and calculus and stuff, you should learn that, you can find patterns like these and deduce that you can create them from power series. So what you want to do is you want to divide by x on both sides, and now you have arctan x over x is equal to the power series from 0 to infinity of x to the 2n times the alternator, -1 to the n, over 2n plus 1. Now, the sum is actually equal to arctan of x over x. So what you really want to do here is you want to solve for x, because if you solve for x, you could just plug in the value and then you'll be able to sum the series. Now, what I recommend is So what I recommend is that you use what you know, the original series that was given, and you can solve for x now that you know that there's a series from 0 to infinity of something times an alternator over 2n plus 1. In this case, it's 1/3 to the n. If you don't know why 3 to the n in the denominator is not equal to 1/3 to the n, you should definitely know that they are in fact equal, and that's math. So you have x to the 2n is equal to 1 over 3 to the n. You can do this because once you have this x to the 2n and you have this 3 to the n, you need to find a value of x that satisfies this and basically becomes that series. So once you have an x that can connect these two series, then okay, now that I have a concrete x value and that x value makes this series into this series, then you can just use that x value and you'll know that it's foolproof for arctan of x over x to sum it. Now you take the root of n on both sides, so you have x squared equals 1/3, and then you wind up with x equals 1 over the square root of 3. Now for most of you, now that you know that x is equal to 1 over the square root of 3, the rest of the problem becomes pretty straightforward. All you have to do is plug in that value of x to arctan over x, and then you have your answer. So let me do that right now. So these series are kind of it really is all about how you whether or not you're able to see the pattern to begin with. So once you're given something like once you're given something with a something over 2n plus 1, you know that okay, this is probably arctan. Or if you see 2n factorial in the denominator, you'll know, oh, okay, that's probably the power series of cosine. So now you have arctan of 1 over rad 3, which, oh, of course, something I forgot to do here because I was just skimming it over. You have to multiply by 2 rad 3 so that the series are always exactly equal. So yeah, if you don't do that, you're gonna wind up getting an answer that's not right. So sorry about that. If you were confused earlier, I'll make sure there's an annotation earlier in the video pointing that out. So then you have that over that. You can take the reciprocal of this and multiply it by whatever you have there. So you have 6 times pi over 6. And you don't know that arctan of x equals pi over 6. Arctan of 1 over rad 3 equals pi over 6. If you don't know that, you should brush up on your trig, because that's something you should be able to remember. So then you get pi. And what I like about this solution is it's elegant once you're able to see the pattern that the problem calls for. But I hope this was helpful. Hopefully it's a very elegant solution. Thanks for watching.